Assalamualaikum warahmatullahi wabarakatuh. This is Group 1 and we are going to talk about nuclear power plants. A nuclear power plant is a sizable industrial facility built to use the heat generated by controlled nuclear fusion to create energy. The main goal is to generate electricity. It relies on the breaking of uranium atoms to unleash enormous amount of energy. This is in contrast to conventional power plants that burn fossil fuels like coal, oil, or natural gases. The enormous heat produced by fusion is used in a specific way. Steam is created using this heat, and the steam powers turbines that are linked to electrical generators. What is fusion? Nuclear fusion is the splitting of heavy atomic nuclei, such as uranium. This process releases two critical elements, heat and neutrons. And the outcome? The splitting of uranium atoms produces a large amount of heat energy. Fusion is initiated by a precise event, where a neutron hits a uranium nucleus, and this impact causes the nucleus to break apart. Fusion is harnessed to provide continuous usable energy. It starts a controlled chain reaction that provides constant heat in the reactor core, and this heat powers the steam used to ultimately generate electricity. Now let's take a look at the components of a nuclear power plant. First part, we have the reactor core and control. First, there's fuel, which is enriched uranium oxide in the form of solid pellets or rods, where fusion reactions occur, acting as both energy and neutron sources to maintain the chain reaction. Next, we have the reactor vessel, a steel house for the nuclear reactor containing the core where the fusion chain reaction takes place. After that, we have the control rods, a reactor control elements made of neutron absorbents, for example, indium cadmium or boron carbide. They control the neutron population and reactor reactivity during operation. Next, we have the pressurizer, a component in the primary cooling circuit that balances liquid and vapor phases to control the pressure. And lastly, we have the containment building, a building that houses the reactor and cooling systems. It acts as shielding in normal operation and prevents the leakage of polluting fusion products to the exterior in case of accidents. The second part is the heat exchange and steam cycle. First, we have the vapor generator, a heat exchanger that uses hot cooling water from the primary circuit to yield heat to the secondary circuit water, turning it into steam. And then the condensator, a heat exchanger composed of tubes where cooling water circulates. It liquefies the steam coming from the turbine, creating a vacuum that improves the turbine's performance. And lastly, we have the turbine, a device that receives the steam and transforms its energy via paddles into mechanical rotation and power. Its axis is attached to the alternator axis.
Next, we will be exploring the internal workings and broader impacts of nuclear power plants. We begin with the final stage of the process, generating and moving electricity. Two key components make this possible. First, we have the alternator. This vital device converts the mechanical rotation energy, which comes from the steam turbine, into medium power, high-intensity electrical energy. It is essentially where the work of the plant becomes the power we use. Second, we have the transformer. Because electricity loses energy during long-distance travel, the transformer raises the voltage of the electricity produced by the alternator. This minimizes losses during transport, ensuring that the power reaches your home or business efficiently. Together, these components ensure that the energy captured from a nuclear reaction is successfully delivered to the national grid. Next, safety and efficiency in a nuclear plant depend heavily on its cooling system. This system prevents overheating and allows the cycle to continue indefinitely. The first element is the cooling water. This water is typically sourced from nearby natural bodies like rivers, reservoirs, or the sea. In an open cycle, it is used to liquefy steam in the condenser and then returned to its source. In a closed cycle, it is reused after being cooled by the second major component, the cooling tower. The cooling tower is the iconic structure people often associate with nuclear plants. It acts as a heat sink, releasing residual heat from the electricity generation process into the atmosphere. This process cools the water circulating inside the condenser, which is a critical part of the plant's auxiliary cooling circuits, ensuring the reactor remains at a stable operating temperature. What happens in a nuclear power plant? Let's look at the step-by-step process of how power is actually created. It all starts with nuclear fission inside the reactor, a process that releases an immense amount of heat. This heat is then transferred to a coolant, which can be water, sodium or metal alloy depending on its specific reactor type. As the coolant absorbs the heat, it enters a steam generator to produce high-pressure steam. This steam flows directly to a turbine generator where its thermal energy is converted into mechanical energy by spinning the turbine blades. The connected generator then converts that mechanical rotation into the electrical energy we talked about earlier. Finally, to keep the cycle going, the steam is cooled back into water and returned to the start. It is a continuous, highly engineered loop of energy transformation. Turning our attention to Malaysia, it is important to clarify that we currently do not have any operational nuclear power plants for commercial electricity. However, we have been active in nuclear research for decades. Since 1982, Malaysia has operated a single nuclear research reactor known as Triga Puspati. Beyond energy, nuclear technology supports other sectors in Malaysia, such as the Flora Vitro Laboratory. This commercial tissue culture laboratory uses advanced techniques to produce plant seedlings. Fully operational since 2002, it features aseptic transfer rooms and incubation areas capable of producing 1.8 million plants per year. This shows that while Malaysia is still investigating nuclear energy as an alternate source for the future, we are already using nuclear science for consultancy and large-scale agriculture production. Why do nations consider nuclear power? There are several major advantages. First is the efficiency. Nuclear plants provide a very high energy output from a relatively small amount of fuel. This leads to the second benefit, which is less fuel is needed, which significantly reduces the logistical needs and cost of transporting fuel. Third, nuclear energy is a cleaner bridge for the environment because it has low carbon emissions, producing almost zero carbon dioxide (CO2) during its actual operation. Fourth, it is incredibly stable and reliable. Unlike some renewable sources, a nuclear plant can run non-stop for 18 to 24 months without refueling. Finally, because of this massive steady output, it is an excellent solution for meeting the large-scale electricity demands of an entire nation. Despite the benefits, nuclear power comes with significant challenges that cannot be ignored. The most well-known issue is radioactive waste, which remains dangerous for thousands of years and requires secure, long-term storage solutions. Then there is the financial hurdle. High construction costs often reach into billions of dollars per plant. Which nuclear energy is generally safe, the risk of a rare but severe accidents like those at Chernobyl or Fukushima remains a major concern. These plants also require highly trained operators and extremely advanced technology to run safely. This leads to a strong public resistance fueled by the fear of radiation. Because of these factors, any nuclear project requires incredibly strict safety regulations and complex emergency systems to protect the surrounding population. In conclusion, nuclear power plants are incredibly effective facilities. They transform regulated nuclear fission energy into heat, then mechanical energy, and finally into the electricity that powers our modern life. They offer a reliable, extensive supply of power with extremely low carbon emissions, making them a tempting choice for a sustainable future. However, we must balance these benefits against the drawbacks, such as waste management, high costs, and safety hazards. Success in nuclear energy requires careful planning, qualified workers, and cutting-edge technology. For nations like Malaysia, the journey involves continued investigation into nuclear as a potential role player in a clean and dependable power strategy for the future.